Welcome to Senior High School Mathematics. Let us have logical operators under General Mathematics, Quarter 2, Week 7, based on curriculum implementation and learning management matrix for K-12's most essential learning competencies. Here are our learning competencies. Introduce how to construct a truth table. Perform the different types of operations on propositions. Before we continue, let us ponder on this. Take fast hold of instruction. Let her not go. Keep her, for she is thy life. Proverbs chapter 4 verse 14 from the King James Bible. Let us start with the definition of a truth table. Given a proposition, its truth table shows all its possible truth values. Let us have an example. Since a proposition has two truth values, a proposition P would have the following truth table. So for a proposition P, from the definition of a proposition, it can only be true or false. So there will be two rows on the truth table for a single proposition P. Truth tables can also be used to display various combinations of truth values of two propositions P and Q. Let's say we have the proposition P and Q. A possible combination is that both P and Q are true. Also, one of the propositions P and Q is true and the other is false. Or both of the propositions P and Q are false. The rows of the table will correspond to the truth value combination of P and Q. Since we have two propositions, then there will be 2 raised to 2 or 4 number of rows. Similarly, suppose we have P, Q, and R as propositions. So we have 3 propositions, and the truth matrix for these 3 propositions may have the truth values as true for all 3, and then we can have one of the propositions false and the other 2 are true. So we may have true, true, false, true, false, true, and the other false, true, true. And then we can also have 2 propositions are false and the other one is true. So we can have true, false, 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 true, false, and false, false, true. Also, we can have all 3 propositions as false. Then the truth table involving 3 propositions will have 2 to the 3rd power or 8 rows. In general, a truth table involving n number of propositions has 2 raised to n rows. So if our proposition has 4 component propositions, then the truth table will have 2 raised to 4 rows or 16 rows. Let us proceed with logical operators. Many mathematical statements are constructed by combining one or more propositions, either simple or compound. These new propositions are formed from existing propositions using logical operators. The logical operators that are used to form new propositions from 2 or more existing propositions are called connectives. We have the first logical operator for negation. Let P be a proposition. The statement, "It is not the case that P," is another proposition, a compound proposition. This is called the negation of P, denoted by not P. or we use the symbol tilde, not P. The proposition not P is read as not P. The symbol for the negation is read as not P if the proposition is P. Other reference or books use this symbol for not P or the negation of P. The truth table for the negation of a proposition is illustrated by the following table. So we have the proposition P. If P is true, then the negation of P or not P is false. When the proposition is false, not P is true. Let us have some example. State the negation of the following propositions. Proposition P is f of x is equal to x minus 1 over x plus 2 is a polynomial function. Proposition Q, 2 is an odd integer. Proposition R, everyone in Visayas speaks Cebuano. Let's start with proposition P. Not P, therefore, it is not true that f of x is equal to x minus 1 over x plus 2 is a polynomial function. Or you just say f of x equals x minus 1 over x plus 2 is not a polynomial function. Let us proceed to proposition Q. Proposition not Q, 2 is not an odd integer. Proposition not R, not everyone in Visayas speaks Cebuano. Okay, let us proceed to the next one. Conjunction. Let P and Q be propositions. The proposition P and Q denoted by P and Q, that's a caret, is the proposition that is true when both P and Q are true and is false otherwise. So the conjunction of P and Q will only be true if both P and Q are true, otherwise false. The proposition P and Q is called the conjunction of P and Q. Let us show the truth matrix for the conjunction of two propositions. Now we have two propositions P and Q. Again, we will have 4 rows in its truth matrix or table. So for the conjunction of propositions P and Q, if P is true and Q is true, then P and Q is true. Otherwise, P and Q is false. The propositions P and Q in the conjunction of the two propositions are called conjuncts. Let us have an example. Number 3. Let P and Q be the propositions. P is the proposition angels exist. Q is the proposition pi is greater than 3. Express the following conjunctions in English sentences or in symbols as the case may be. Letter A, P and Q. Letter B, P and not Q. Letter C, angels do not exist and pi is less than or equal to 3. Letter D, while angels do not exist and pi is greater than 3. Let's start with letter A. P and Q therefore would be the proposition angels exist and pi is greater than 3. So that is the conjunction of P and Q. Next, let us have letter B. Angel exists, yet pi is less than or equal to 3. That is the negation of pi is greater than 3. Or we may say angels exist and pi is not greater than 3. Let us go to letter C. Angels do not exist, so that is the negation of the proposition P, and conjunction pi is less than or equal to 3, that is the negation of proposition Q. Therefore, we have the symbol not P and not Q. Let us proceed to letter D. While angels do not exist, that is the negation of proposition P, and pi is greater than 3, that is proposition Q, so that is not P and Q. Disjunction. Let P and Q be propositions. The proposition P or Q denoted by P or Q is the proposition that is false when both P and Q are false and is true otherwise. So P or Q, or the disjunction of the propositions P or Q, will only be false when both P and Q are false. Other combinations of the truth values of the two propositions are true. The proposition P or Q is called the disjunction of P and Q. Let us have the truth matrix for the disjunction of the propositions. So we start with the possible combinations of the truth values for P and Q. Then for the disjunction P or Q will be true when both P and Q are true. True also when P is true, Q is false. True also when P is false and Q is true. So that means at least one of the two proposition is true, then the disjunction of the two proposition will be true. Otherwise, if both the propositions P and Q are false, then the disjunction P or Q is false. The propositions P and Q are called disjuncts. Let us have another example. Let P, Q, and R be the following propositions. P is the proposition Victor has a date with Lisa. Q is the proposition January is sleeping. R is the proposition Yumir is eating. Express the following propositions in English sentences or in symbols, as the case may be. Letter A, we have P or Q. Letter B, Q or not R. Letter C, P or Q and R. So let's have letter A. That is the disjunction of the propositions P and Q. Therefore, we have P, that is Victor has a date with Lisa, or January is sleeping. Victor has a date with Lisa, or January is sleeping. Let us go to letter D. The disjunction Q or not R. So that is either January is sleeping, or the negation or R, Yumir is not eating. So that is either January is sleeping or Yumir is not eating. Letter C. Either Victor has a date with Lisa, or January is sleeping and Yumir is eating. Let us have another set. Letter D. Either Victor has a date with Lisa, or January is sleeping, or Yumir is eating. Letter E. Either Yumir is eating, or January is sleeping, and Victor has a date with Lisa. Let us have letter D. That is P or Q or R. we have a comma before or Yumir is eating, hence we may group Victor has a date with Lisa or January is sleeping. So that is parenthesis P or Q, close parenthesis, or R. Letter E. Either Yumir is eating, comma, or January is sleeping and Victor has a date with Lisa. So that will be R or parenthesis Q and P, close parenthesis. Let's have another example. Number 5. Let P, Q, and R be the following proposition. Consider the scenario that one day night, Victor and January are studying for their logic exam. Meanwhile, Yumir just tweeted a picture of himself eating crispy pata and sisig. What is the truth value of the proposition not P or parenthesis Q and R? This time, we're going to use the truth matrix or table to find the truth value of this compound proposition. So in this proposition, we will need P, Q, and R. The proposition P is Victor has a date with Lisa. However, in our scenario, Victor and January are studying for their logic exam. So it is not true that Victor has a date with Lisa. Therefore, P is false. Proposition Q is January is sleeping. The same scenario that Victor and January are studying for their logic exam, hence Q is also false. Next, R is the proposition Yumir is eating. In our scenario, Yumir just tweeted a picture of himself eating crispy pata and sisig. Therefore, the proposition R is true. We will need not P, and then the conjunction Q and R, and then the proposition not P or Q and R. So as we discussed, P is false, Q is false, R is true. The negation of P is true because the proposition P is false. The conjunction Q and R is false because Q is false and R is true. For the conjunction to be true, both Q and R must be true. Hence, this is false. Now, the disjunction not P or Q and R, we have the proposition not P as true and the proposition Q and R false. Hence, the disjunction is true. Because for the disjunction, both proposition must be false before it will be false. At least one of the proposition is true, the disjunction is true. Hence, the truth value of the proposition is true. Let us proceed to conditional or implication. Let P and Q be propositions. The implication P arrow Q is the proposition that is false when P is true and Q is false, and is true otherwise. In this implication, P is called the premise or the hypothesis, and Q is called the consequence or conclusion. In other reference, this is called the conditional statement. P implies Q. Or we say, if P, then Q. The truth matrix for the implication or conditional statement P implies Q, or if P then Q, are the following. If both P and Q are true, then P implies Q is true. If P is true, or if the hypothesis is true and the conclusion is false, the implication is false. If the hypothesis is false and the conclusion is true, then the implication is true. Now, if both the hypothesis and conclusion are false, the implication is true. The proposition P, again, is called the hypothesis, and Q is the conclusion. Let us have some examples. Suppose that GB is a grade 11 student. Consider the following conditionals. The proposition P, if GB is in grade 11, then she is a senior high school student. Proposition S, if GB is in grade 11, then she is working as a lawyer. If GB has a degree in computer science, then she believes in true love. Now, we consider in answering the truth value of these conditionals, we will consider the truth matrix for implication. So we're going to analyze the truth value of the following conditionals. Letter P, or proposition P. It is true that GB is in grade 11. It is also true that if she is in grade 11, she is a senior high school student. Therefore, the hypothesis is true, the conclusion is true, the conditional therefore is true. Next, the hypothesis is true, GB is in grade 11. The conclusion, she is working as a lawyer, is false, since GB is still a student. So the hypothesis is true, the conclusion is false. By the truth matrix, this conditional is false. Next, proposition T. GB has a degree in computer science. This hypothesis is false, because we know that GB is a grade 11 student. Let's go to the conclusion. Then she believes in true love. The conclusion is either true or false. However, the hypothesis is false, and by the truth matrix for conditional, regardless of the truth value of the conclusion, proposition T will be true. The conditional statement is not new to us senior high school students, because in grade 8 geometry, we learned about conditional statement, converse statement, inverse statement, and contrapositive statement. The converse, inverse, and contrapositive of a statement are based from the conditional statement. These are the related implications that can be formed from the conditional statement. If the conditional statement is P implies Q, or if P, then Q. Number 1, converse. The proposition Q implies P is called the converse of P implies Q. From the conditional statement, P is the hypothesis, Q is the conclusion. It becomes the converse of its conditional if Q now is the hypothesis and P is the conclusion. Next, the proposition not P implies not Q is called the inverse of the conditional statement if P then Q. So the negation of the hypothesis implies the negation of the conclusion is the inverse statement. Next, the converse of the inverse statement is the contrapositive of the conditional statement. So the proposition if not Q, then not P is called the contrapositive of If P, then Q. Let us have the next one, biconditional. Let P and Q be propositions. The biconditional P if and only if Q is the proposition that is true when P and Q have the same truth values and is false otherwise. So the biconditional will be true if P and Q have the same truth value. The biconditional is formed when the conditional statement and the converse statement are true. So it is read as P if and only if Q, Q if and only if P, or P implies Q and Q implies P. Let us have the truth table for the biconditional. Again, we have 4 rows. We are dealing with 2 propositions, P and Q. So the proposition P if and only if Q will have a truth value of true if both P and Q have the same truth value. P is true, Q is true. Biconditional is true. If P and Q have different truth values, then the biconditional statement will have a truth value false. Again, both P and Q are false in the last combination, therefore the biconditional is true. Let's have an example on this. Suppose that GB is a grade 11 student. Consider the following conditionals. Proposition P, GB is in grade 11 if and only if she is a senior high school student. Proposition S, GB is in grade 11 if and only if she is working as a lawyer. Proposition T, GB has a degree in computer science if and only if she believes in true love. Let's start with proposition P. Proposition P is true since the first proposition, GB is in grade 11, is true. And the second proposition, she is a senior high school student, that is also true. Therefore, proposition P is true. Proposition S, GB is in grade 11, that is true. The other one, she is working as a lawyer, which is false, since GB is still a grade 11 student. So true if and only if false yields a false truth value. GB has a degree in computer science, that is false, since GB is still a grade 11 student. She believes in true love. So the truth value for proposition T will depend on the truth value of the second component. She believes in true love. That will be all. Exercises on this topic may be downloaded from the link given on the description of the video. Thank you for watching. Please subscribe for more math lessons.